and welcome to Hardwood Floors Magazine's Product Theater Thursday, part of the NWFA's Live Ed series. I'm Libby Johnston, publisher of Hardwood Floors, the official magazine of NWFA. Today's theater is sponsored by LATICRETE International, a manufacturer of construction solutions for the building industry. Joining me now is Joe Rizzo, Director of Sales, and Elvis Torres, Product Manager for LATICRETE. Thank you for being with us on Product Theater Thursday.
Thank you for having us. It's a pleasure to be here.
I know that you're going to talk a little bit about preventing moisture problems on flooring before they occur. Can you tell us a little more about what we'll hear about in your presentation today?
Absolutely. So we're going to cover a wide array. Without getting too deep into what's already covered in the presentation, in the most basic of terms, we're going to talk about how sneaky water can be, where it can come from, what it can do, and then most importantly, how it can be prevented from causing problems.
Right, sounds good. I'd like to remind everyone that's with us to type questions into the questions pane throughout the presentation, and we'll work to answer them afterward. Okay, and Elvis, I am now going to turn things over to you.
Sounds like a plan, thank you. So hopefully that's coming in clear there.
I see it.
Perfect. Thanks, Joe. All right, everyone. Well, thank you so much for joining us today. Again, my name is Elvis Torres. I'm the product manager for the Concrete Substrate Preparation Division, and Joe Rizzo is our sales director. So Joe's going to be going over the agenda for today. Is that Joe's going to be going over pretty much the intro, what to look at for moisture mitigation, and then I'm going to kind of review some of the products that we offer for that, and then kind of going into just quick showing prep and what could be done to kind of start installing our moisture vapor barriers. So, but a quick thing on the company and their overview. We're a family-owned company established in 1956. We were actually the ones that invented the first modified thin set for tile and stone insulation. Our headquarters is here in Bethany, Connecticut, where we have a large array of R&D, our manufacturing, and our technical services. But we also have multiple plants around the country and also around the world. As you can see, that here's one of the images. So we have we're in over 100 countries. We have over 1,900 employees. Again, U.S., the North American being our home base, and then we are just slowly but surely expanding our reach across the world, offering everyone's products from tile and stone installation, concrete substrate repair, which includes moisture mitigation, which we're talking about today, patches and skims, self-levelers, overlays, and then tile adhesives, thin sets, shower systems, profiles, metal profiles, PVC, everything along and accessories needed for perfect tile installation. So, and here you go, Joe.
All right. Well, I appreciate it, and you guys are lucky today for a technological reason beyond our control. My camera is not working, so I can't get on camera, which is a very good thing. Many people will tell you that my face is hidden away from the general public. All kidding aside, if you guys are in the tile business, you would know LATICRETE because that's where we got our start. But because we are a company that treasures and values innovation, we've expanded our business over the last almost 7 decades. And the expertise that we've developed in preventing problems with substrate preparation and moisture mitigation for all types of systems, flooring systems, can benefit any type of flooring installation. So to zone in on the specifics of what we're going to talk about today, there are a number of issues that can be caused by moisture in concrete that we're going to be looking at and talking about in detail. And I encourage everybody that if they pick up on something that they think there may be a little bit more information than what we covered in the slides themselves, please put your questions so that we can address your specific concerns regarding the issues that are caused by moisture, where the moisture comes from. You'll be surprised possibly at how many different sources moisture can be present in, and some of them are obvious, some of them are a little sneaky. Water can be insidious. There are good news that test methods that are used for either testing the presence or even the quantity of moisture, and that will help determine what kind of problems you can expect, but also lead you to a solution. A very high level of continuous moisture may need more of a solution than a lower level non-continuous, and we'll be looking at that. Different types of floors are different in their sensitivity to moisture, and wood happens to be amongst the most sensitive of all. And then we're going to shift from what the problems are and where they come from to what the solutions are in terms of product and the range of products that's available to help, how to prep a substrate for moisture mitigation, and also the installation techniques for installing the products so that you can basically be able to protect against almost any level of moisture using these products when they're properly installed. What you see in the picture there is a very typical problematic substrate that has been subjected to a significant amount of moisture. There are two things that are going on in the pictures that you're viewing. One is because of the chemical changes that occur in a concrete substrate, because of moisture, and we'll look at the chemistry of it in a light way. We're not going to get too deep into chemistry. The glues themselves break down because of the moisture and because of the pH of the concrete, which is exacerbated by moisture. But the other thing that happens is salts are brought up. So you have a number of issues: the wetness itself, the chemical makeup, and the salts, which go by the name of efflorescence, that come up through and can make for an unsightly concrete that is also very difficult to adhere flooring. Next, please. The first place to start, if we are lucky enough to be involved for a project from the time before the concrete is poured, that concrete design can be made, can be executed so that we minimize the amount of moisture which is found in the concrete itself. That is one of the major sources of moisture. Concrete gets mixed with enough water to do two things. Concrete does not dry after the water is added, which is something very typically said by many people. Concrete instead hydrates. In other words, the cement in the concrete being a mix of cement, sand, and stone, the cement reacts with the water in a process called hydration and becomes that hard, strong substance that we know. However, most concrete is mixed with enough water beyond the water of hydration, the free water, which is essentially there for no other reason to make the concrete placeable. If we put in just enough water to hydrate the concrete, chances are it would be very, very difficult to place. That extra water, which is wonderful for placing the concrete, however, afterwards has to come out of the concrete. And depending on what type of floor we're using, what type of glue we're using, that can be problematic because just as its name, free water, implies, free water may interact with the rest of our system once that water leaves the concrete. Next slide, please. We see here a little bit more of a detailed picture of the efflorescence. These are the salts that come through. And again, the effect can be chemical as well as aesthetic, as well as causing a soft powdery surface. So even if it was a neutral salt, for example, it's still very difficult to adhere to. A couple of things to note about efflorescence. We're going to look at the different types of slabs, whether a slab is elevated or whether a slab is on ground. If efflorescence is showing on a slab that is on ground, that typically means that we've got water coming through the ground, through the concrete, and carrying salt with it. Even if we clean it, there is a very good chance, if we are on ground, that there could be more water in the ground, depending on where the water table is and the specifics of the location, which means that if we do nothing more than clean the efflorescence and then put down a floor that is on ground, or some people refer to it as on grade, we have a very distinct possibility that after we've covered up the concrete with flooring, we get water coming through, which is going to cause us further problems, both with the glue and with the flooring itself. Next slide, please. So if the slab is on grade with a vapor barrier, or if the slab is elevated, by the way, when I say with a vapor barrier, I'm talking about a 4 to 6 mil piece of plastic that is usually laid out on the ground prior to pouring the concrete. And the width that I'm saying here, that with the vapor barrier, implies that that vapor barrier is intact. So if we have no possibility of water entering concrete from the ground, that means that the water that we're seeing is water that was in the concrete itself that is now coming out, what I referred to before as the free water. However, if we are on a slab on grade with a vapor barrier that might have been compromised or no vapor barrier at all, there is a very good chance that we have a continuous feeding of water. I'll give you an example. If we go into an existing building and we look at a slab that was placed 10 years ago, the slab that is elevated should be pretty much bone dry because it's had 10 years, unless that water was trapped, it's had 10 years to lose its moisture, either from the bottom or from the top. However, 10 years after construction for a slab on grade means nothing at all because we're not looking at a confined set amount of water. We're looking at an amount of water that could be infinite because it's coming up from the ground itself. In very practical terms, if you are working in a basement or on a foundation slab, be very, very weary. Even if the slab appears dry, there's always a possibility that it will be fed moisture at some point, maybe in a different season where the temperature changes. Next slide, please. Here's the one that nobody thinks about. What are obvious water sources to some people are not obvious water sources because we're not always thinking in context. We're thinking about what's going on with the concrete. Is it elevated? Is it on grade? Is it coming from the free water? Is it coming from the ground? But then there's the obvious stuff. Are the slabs outside the house sloped downwards and away from the house instead of having a negative slope, which brings water towards the house? I'm chuckling as I'm saying this because my house actually had that problem. It would rain and the contractor had sloped backwards instead of away from the house. So every time it rained, there was water coming right into my basement from the outside. Something is obvious. Are the gutters working properly? Is the water being carried away from the house? And are the sources of water that are going into the house, the water supply lines, have they been compromised? I've seen cases where it wasn't even water supply lines that caused moisture that no one could figure out where they were coming from. It was actually the exit lines, the sewer lines that were compromised and were feeding water into the house. So we want to make sure that we know where our water is coming from. Next, please. The first and most obvious indication of moisture on a slab in or around the structure is the simple one that isn't even measured here. If there's water damage or obvious moisture that can be seen by eye, obviously there's a moisture problem. That one is so obvious that it's not a test method. But there are 3 different test methods that range from the most basic, that 4263 ASTM test the plastic sheet method is a very basic method, to some that are more involved that can tell us how much moisture and how much humidity is available, not available, excuse me, is present in the slab that can be a problem for us. Next, please. ASTM 1869 is very commonly referred to as a calcium chloride test. It is simple in that essentially calcium chloride will grab moisture that is around it. It is extremely hydrophilic, to use the chemical term, so the water gets soaked up in that calcium chloride. What the test does is, first, we open up a pathway for the moisture to be able to escape from the slab. And when I say a pathway, I mean we put some profiling and open up the pores of the concrete to allow moisture to escape. We then put a dish that is filled with a known amount of calcium chloride, and we trap that with a plastic cover that is impermeable. So we know that for that 1 square foot of plastic that we've got around this Petri dish, every bit of moisture is going to be absorbed by this hydrophilic calcium chloride. The calcium chloride has been weighed while it's still dry, and then 60 to 72 hours later, we weigh it again. Whatever the weight difference is the weight of the moisture. And I'm sure many of you have seen that there is a line in flooring installation and even in glue product data sheets that says the moisture should not exceed 3 pounds per 1,000 square feet. So we have a weight of water from this test. The potential problems with this test are that there may or may not be enough time, even with the proper amount of time, for all the moisture to escape in a 60 to 72 hour period. So you may be getting a little bit of a surface condition. However, it is a fairly reliable test. Next slide, please. What the industry seems to have gravitated towards is relative humidity. Here's a test that instead of measuring water, measures the percentage of water, the percentage of moisture that is in the concrete compared to the total amount of moisture that could potentially theoretically be in the concrete. So if we imagine concrete as a very porous, rigid sponge, we know that there's a certain amount of moisture that's theoretically possible to fill a given volume of concrete. That's what 100% relative humidity would be. We drill a hole that's 40% the depth of the concrete of a slab on grade. We then put that probe that is shown in the picture. We allow it to equilibrate for 24 hours. Essentially, we allow it to soak up the moisture. And a reading is taken from this probe that will tell us whether we have 50, 60, 70, 100% relative humidity. That's another line item that you've seen on specs, flooring and manufacturer's instructions, and flooring adhesive manufacturer's instructions. And you'll see this glue can tolerate 75% moisture. This glue can tolerate 85% moisture, 95% moisture, and so forth. This is where moisture mitigation then comes in. If we are exceeding in our relative humidity tests the amount of moisture that is allowable in a particular type of flooring or adhesive. Next, please. Here's our basic test, and it's actually not a bad place to start. 4 square foot, 2 foot by 2 foot piece of plastic is taped on concrete that has been profiled a little bit. The plastic remains in place for 24 hours. If it looks wet underneath, chances are you've got enough moisture. If there's enough moisture to come up and be visible in a piece of plastic, the chances are that's enough moisture that will give you problems when you install your flooring. The one final thing to say before shifting into our next phase of what can we do about this moisture problem is that glues have gotten better and better and better and there are now some glues which are extremely highly moisture tolerant. That is a very positive thing for the installation of wood flooring, but keep in mind what that means is that the glue itself will not fall apart. It does not necessarily mean that the glue will prevent the passage of moisture into the wood floor. So I did want to mention that at this juncture. Next, please. We talked about the actual sources of moisture. Here's a little bit of what can happen. So there are two types of flooring that are moisture sensitive. When we're talking about a flooring that it blocks the moisture, then it is trapped and we may see bubbling in the flooring itself. And we'll see a little bit later on that wood has its own unique set of problems because wood does not necessarily block the passing of moisture. However, it can be severely affected not only in the glue, but the flooring itself. The chemistry of a slab is one that its chemical makeup, if there's a chemical problem in a concrete slab, it won't be transferred to a glue or a floor if that slab is dry. However, if the slab has moisture coming through it, water not only carries water pressure from a slab on grade, which is a mechanical problem, it also carries through all the chemical problems, which is what breaks down our glue, as well as the water itself. Next, please. So what we see here in moisture-sensitive flooring that is wood, the moisture can come up through and cause cupping, mold, all sorts of deformations of the floor itself. In a resilient floor, like you see on the top right third picture, the flooring itself is not water permeable or water pervious, but what that causes is a situation where you see bubbling under the floor. So we actually have a little bit more sensitivity with wood flooring than we do with flooring that is non-pervious, the destruction of the floor itself as well as the compromise of the glue. Next slide, please. And of course, being that we live a lot in the world of tile, we wanted to show you what can happen with a tile installation. Tile itself is not necessarily going to be compromised by moisture. You're talking about a porcelain or ceramic that doesn't break down. You're talking about a cement-based adhesive system which does not break down. But if there's too much moisture, water can come up through the grout line and with it push all those ugly salts. So even though the strength of the flooring that you're seeing in this picture has not been compromised, I'm going to say that an owner would not be happy if after a brand new tile installation, a week or 2 weeks or a couple of months later, they saw all this efflorescence and salt and moisture coming through their brand new tile floor. Next, please. Well, you got the boring part from me, and now the fun part, because he's going to tell you how you can fix all these problems. Take her away.
Thanks, Joe. I appreciate it. Always great to see those intros. So here at LATICRETE, we offer 3 different solutions to apply moisture mitigation to a floor. Now, they're all epoxy based, and really ease of convenience and speed is what really separates the 3. So our entry level, I say entry level, but still a pretty high performing product because of the fact that it exceeds the ASTM F3010 testing for moisture mitigation, which is below 0.1 perm. So I mean, that's the best that you're going to get out there. And the interesting thing about this product is that it's rated speed. So you know, it's rated for the most aggressive situation. You know, you're going to bring down pressure from 25 pounds down to 3 pounds. And it's going to be about 12 hours of a cure. So let's just say that there's a couple situations, right? Your slab can be already nice and flat, but you have moisture issues. So you're applying the moisture barrier And then from there, you're going to lay down your glue and then your final finish, right? Whatever it may be. Or, there's situations where, you may need to level the floor. So you would do the moisture mitigation first and then level. So this product requires a primer after it is fully cured, which again is 12 hours. So you would use one of our primers, either our Primer Plus, which you can actually broadcast, you can apply to the floor and broadcast powder into it and make into it like a little bit of a slurry bond coat for SLUs. Or the easier approach, which we always recommend, is our Primer Bond, which is a great one component primer that we have that has actually sand built into it. So it creates a great mechanical bond to this product. And again, once it cures, you're able to apply your self-leveler on top and then have your perfectly flat floor for your final finishes. So, wood floors are just, the planks are getting wider and wider, tiles getting bigger and bigger. So the necessity to have a floor that's flat is crucial for those type of applications. So yeah, different combination of products for different applications that that you would need. So that's our number one. And again, using the 3 and the 5 gallon unit, with this product, the 5 gallons much more popular because you're probably doing larger areas. But then you get into the ER, which that equates to our epoxy rapid. So again, high performance, exceeds F3010, 100% RH, bringing that pressure down as well. But with this one, you have the speed. So you're getting all the performance of resisting that moisture and that pressure, but you're doing it in 3 times as fast. So this product cures in 2 to 3 hours, and it just gives you that rapid speed. And again, you would need a primer, your self-leveling, but just to make a note, our skim coat product can easily be applied over or under this product as well. So sometimes some adhesives require a little bit of you can say a kiss coat of a cement-based product. So our skim light can be applied over these products and still bond. So which is very, very, which is great because obviously it's epoxy. Once it cures, it looks like very smooth. So it's great to have that adhesion. But again, great performance with a fast turnaround. And from there, we kind of evolved from this product and said, well, okay, there's always a middle step, as I just explained, right? Having a primer, applying it if you're installing an SLU because you need your floor flat. So how can we always at LATICRETE looking at and improving the time and less amount of effort and product needed? So then we came out with a product called Vapor Band Primer ER. So this is an epoxy, same thing, 2 component, rated as the other ones are for the highest performance, but it has a primer built into it. So this product's going to cure. Again in 2 to 3 hours, but once it's cured, you're not needing to apply a primer on top if you are going to self-level over it. So that's the real nice thing. So it actually has some built-in chemically altered to have that adhesion with the self-leveler, and again, it's saving that time and step. Eliminating the need of having your excess product on the job site. Timing, this is really used for rapid projects that are a quick turnaround. Primarily for us, we see it used a lot in hospital applications because time is money, especially in a hospital application where if you close a hole that's being used obviously for patients and everything like that, that's just a lot of inconvenience. So these are like overnight projects where you're grabbing your fastest SLU, you're grabbing this moisture mitigation, which is extremely fast, and in a day, having a floor nice leveled and potentially having a final floor applied on top. So very rapid and definitely a niche product, but used for sure to just, for those rapid applications. And taking a look at the 3 products I was just talking about now, this is just a nice little chart that kind of separates the 3. Now, currently, we'll give you guys a little insight. We're always looking to innovate, improve, and go with where, the future is looking like. So we are definitely looking to expand this line in the future and add another product in there. We're favoring, obviously, a 1-component moisture barrier, which offers you the same amount of performance. So look forward to the near future of us coming out with even another great product. But, the moisture mitigation, especially an epoxy-based moisture mitigation, is just so tested and true as well, and it's just a big favorite of the industry as well. So we're very happy with the performance of all these products. Again, offering the best, the highest. You can't get any better with either of them and timing is really what separates them. So we're there definitely to assist in any type of unique application that you're doing. And you know, Joe mentioned it a lot in his previous presentation that, you know, sometimes this is even a great added insurance. You know, I think a lot of times that comes up in situations when we're on projects is that you don't know you need it until you need it. So a lot of times these products are not spec'd in or talked about in advance, or owners are warned about potentially having this issue. So it's always nice to kind of bring it up front and say, hey, you know, based on what your slab is going to be in the future, just letting you know you might need a moisture barrier. Because again, these are they're going to take more time, they're going to take more effort, and the product itself, the cost of it. So it's not a topic that a lot of people like to talk about because they think that everything is perfect and they're not going to need one. So just always go into a project knowing that, hey, I might need a moisture mitigant. I should be testing it per the test methods that Joe talked about, and just covering yourself to make that conversation easier, obviously, with the owner and down the road, and just letting them know that, hey, you may have an issue here, and obviously we want this floor to last for a very, very long time. So it's just one of those topics just to talk about up front and not to forget about.
Elvis, if I just very quickly add
one
positive spin on it. Yes, the moisture is a problem, but for us in the industry, it's also an opportunity for an upsell. And there's nothing wrong with that because we're providing a consultative solution to an owner, but we're also finding the opportunity to upsell our goods and services. So that is the one positive thing about mitigating.
No, absolutely. Good point, Joe. So we wanted to show you some pictures and then some final applications that kind of were done. So when as you saw in the very beginning, Joe was kind of talking and going over that picture where you saw the hand with all the glue all over it. I mean, that's what you're going to get once you remove either a wood floor, vinyl, whatever it may be, right? If there's moisture that was present and the floor was ruined, you're taking that up. So obviously removing contaminants is really important, and kind of wanted to go through the array of equipment that potentially can be used. Now, our products require a CSP of 3 to 5. So the E and the ER require a surface prep of 3 to 5. Our ER, we've designed it to have even a little bit less surface prep, so anything from 1 to 3, which is not a lot. So obviously these can all be adjusted with different equipment and rates and type of tooling that you're using to get a more aggressive or softer approach. But again, it also depends on each project is different as well. But this is a smaller unit, which again will help you get in those nooks and crannies. And depending on the area that you're doing, I mean, this is just going to get larger and larger, as you can see here. So this is quite a large unit where the other one's kind of handling the corners and the nooks and crannies. You're going to have this one that's going to be attacking it in much larger sections, larger hallways, longer runs up and down. So these are actually bits that are traveling under there in a planetary type of style. They're rotating, and also as actually the whole platform is rotating, there's actually tooling in there that's rotating as well at a different speed. And again, that's just kind of removing all the material and afterwards being vacuumed. Vacuums are attached to this material, obviously, to prevent dust. We don't want to be breathing in any of that stuff, and it's becoming more and more of a concern on the job site. And another way to do it is actually shot blasting. So as you have that mechanical bite before, you know, as it's rotating on the ground and kind of, you know, cleaning it up and removing all that contaminants, there's another way to do it as well with beads, metal beads. So this machine is actually shooting metal beads into the ground and actually cleaning it. You know, kind of blasting it, if you will, obviously, the material off the surface and leaving you with a nice clean surface. So after you're doing this application, you will walk around with a magnet, pick up whatever beads were not collected by the machine. Obviously, you don't want those rolling around as you're doing the application. So that's just another method of removing, you know, contaminants off of the floor and creating the perfect platform. And then as you're doing this, you're going to start noticing, oh, you know, there's a crack over here. Oh, there's a joint over here. So, you know, our products as well can be mixed with dry silica sands, which you can create a mortar with. So let's just say you have a 1/4 inch to an inch crack. You know, you clean it up, you hollow it out with a chisel. It's now nice and clean. All loose pieces are removed. You can compact that with that mixing it with sand, the moisture mitigation, and again creating a repair. And because a lot of times, and this actually happens on even multi-story buildings as well, sometimes you see a crack and you're like, okay, that's probably not that deep, and you'll just moisture mitigate over it. But these products are so low viscosity that they will actually travel through that crack all the way through. And there's been multiple times where, you know, if you're in a multi-story building, there's a crack in the slab and you haven't attended to it in advance, it could be going down to the following floor and then to the following floor and then, you know, and so on and so forth. So all cracks should be addressed. All that stuff needs to be looked at in advance and just, you know, be prepared for. Either you're repairing it, you know, with a cement-based repair material, or again, you could just take the epoxy, R epoxy, the Vapor Band E or ER, and creating that moisture, that repair, the fill in those cracks will be very, very important, because you don't want to waste material and have a mess. And that's what you're pretty much going to look at, you know, before and after. And this is just obviously the right way to do it, to make sure that your product's going to adhere well to that surface and to create that long-lasting application. So with our products, you know, there's an A and a B, and speed is of the essence with the faster ones, hence why we only offer those in the 3-gallon. The E, which is much more forgiving in time, you know, that's we have a larger unit for that one. But again, keeping this material temperature controlled, out of, you know, they'll keep it in your truck, in the sunlight, in the parking lot right before you're about to do it, because even with self-levelers, cementitious based products, anything chemically, you know, that needs a chemical cure, if you keep it hotter, if you use hot water, if you, whatever it may be, you can increase the reaction time, and then you're going to have a much shorter working time. You know, for self-levelers, for example, you know, you can have a 30 to 40 minute working time, and then you keep all that product in the sunlight without getting it covered, you could be left with 10 to 15 minutes, depending on even how hot the atmosphere is. So you just want to make sure you give yourself the best preparation to do this. This situation and this application that you're actually viewing here, this was a medical application. It was being shut down overnight and had to be open the next day. So everything was being done at night. This was in Florida, so it can be quite hot. But again, that helped the whole situation of keeping the material temperature controlled and just being ready for it. Planning is all definitely a part of before the execution goes as well. So you're going to take the, you know, one of our units, our smaller unit, the A, and then mix it into the B, mix for 2 to 3 minutes. It's always nice to stop in between the mixers, make sure you scrape the sides of the pail, making sure that both chemicals are 100% in there, you know, getting all that cross-linking going on, getting all that chemistry working, and having the product perform 100%. And then you're going to want to pour nice ribbons with the product to get it all nice and spread out. If you don't want to leave it in the container, again, you're leaving a massive product together. It's going to just want to react faster. So the most important thing is to just get the product out of the pail, whether it's our slow version or fast version, doesn't matter. Just get the product onto the floor and then start, you know, begin to start spreading it and getting the product out there. And you can see, you know, notch squeegee does a perfect way. You know, 3/16 notch squeegee, you know, giving you down about 12 mils. All this is in our product data sheet as well as online, and can be reviewed, and it's very, very well documented. And we even have our TDS 238, which is our surface preparation. I'm sorry, TDS 230, which is our substrate preparation guide. So that kind of goes through. It's a nice guide. Kind of lays everything out and lets you know, okay, what are you experiencing? This is the product you should go. This is how you apply that product. So again, we have our product data sheet, and then our TDS, our technical data sheet 230, which can be a great amount of help to you to kind of work through things. And again, if you're working on a situation, you know, our local sales reps are in the area as well, and they're more than willing to help. We have 80 to 90 reps across the country that are at call to just help you out. So the most important thing after, you know, pushing this notch squeegee out, and you see those notches, you're going to want to back roll it. So as that individual is kind of spreading the material, making sure that you have the right millage on the floor and then not wasting any material, not going too little but too much, another individual will come and back roll. So you're going to take that roller and kind of go the opposite direction. So that's a hallway. So that individual was actually going long ways right there. So the ridges were facing the opposite way. But as he starts attacking this hallway, he's going to want to go the opposite direction of the ridges to make sure that floor is, make sure the epoxy is nice and flat on the floor, and the picture all the way on the right is what you're going to be end up with, a nice clean sheen there. So one thing we wanted to mention in this webinar, obviously with the NWFA, we've been in partnership a strategic partnership with Bona. We saw the need to kind of join forces and help each other out, as we currently do not have adhesives for the wood flooring, and they do not have any surface preparation products. So we've been joining forces with them. They've been a phenomenal strategic partner. We have joint warranties with each other. We're both oriented towards the customer, both family-owned companies. There's just so many synergies. Honestly, you couldn't even plan it out as well as it just has worked out. So these are some projects that we worked with each other. A lot of their glues work on top of our moisture mitigation. We've already tested all that, and on top of our self-levelers as well. But we kind of want to show you and mention that to you, because if you have any applications, just to let you know, we're in full support of each other's products, and obviously our customer service, both companies, is top notch. And this is some other beautiful homes that have been done by using both our products. And here's some contact information. So again, you have Joseph Rizzo, who's on the call today. You have Troy Wicks, who's our other sales director in the territory. Aaron Abbott, who's our senior technical manager, our feet on the ground on many of these projects. And then obviously our technical service line, which you can reach at any time. And then obviously me, if you have any product questions or any way I can point you, I will.
Okay, well, let's go ahead and take some questions now. So the first question is, what impact do seasonal changes and temperature fluctuations have on hardwood flooring installations?
Okay, let me jump into that. That is a particularly relevant and great question when we're talking about slabs on grade. Different temperatures will cause different amounts of moisture that can remain in concrete. So we can measure the moisture in the concrete, let's say when it is cold, and the moisture is not being agitated by the energy that's brought by a higher temperature, right? So it all stays in the concrete. And the same as when we, let's say, add heat to water, what do? We start driving off the vapor that ends up in boiling. We're not talking about temperature extremes like that. But as temperature gets higher, more water is driven out from the slab. So we may take a measurement on a cold day or when the building's not acclimated, and it will be a different measurement that possibly fool us into thinking that we have a lower amount of moisture in the floor. So be very aware, be very conscious of the temperature conditions that you're measuring under.
No, that's so true. And again, that's why one of the key things in what Joe was mentioning before with all the testing as well is the last bullet points on each slide was make sure everything's acclimated, with HVAC and heat. So you gotta have that right starting point, and hence why, to Joe's point earlier, why it's so important to avoid those type of different temperature swings and whatever you may experience.
Okay, and another. Sorry, go ahead.
I was going to say it's more fun to work in an acclimated building than a non-heated building that still hasn't been buttoned up. So yeah, yay for the indoors.
Yeah.
Okay, another question. Do you need moisture barriers if you're using 100% RH tolerant flooring glue?
The answer to that is definitely maybe. And here's the conditions. If the flooring that we are applying is sensitive to moisture, so as we repeated a couple of times during the presentation, moisture can affect the glues and moisture can affect the flooring. So 100% relative humidity glue may mean that the glue itself will not break down under severe moisture conditions, and 100% RH is a severe moisture condition. However, it may not prevent the passage of moisture through that glue to get into our wood to cause the wetness, the cupping, the deformation, the water coming through into the space. That's the one thing about the epoxies. They are barrier systems, 100% relative humidity, 100% of stopping that humidity. It's hitting a positive barrier that will not let the moisture get either to the glue or to the floor itself.
Yeah, and I think also what comes into play there is also having 100% coverage. You know, what happens if you miss a spot, a pinhole here, or you just happen not to get a little, even, geez, I mean, even a small area, you're still allowing that moisture to travel through and potentially damage a section, a small part of your floor, but still there is a risk. So great points by Joe, and also just wanted to mention that as well.
Okay, and next question, is a slab in a basement different than on the upper floors?
Yeah, for sure. As Joe had mentioned before, depending on how much, you know, like his example was his home, and obviously having the water kind of not being displaced too far away. Obviously, that moisture is going down and then wants to come back up, and it potentially can go through your slab. And that slab is right on grade. And the problem is that sometimes that moisture barrier that's put between the earth and your concrete slab, it may break. Someone's walking through it during the construction, rips it a little bit, and then you could potentially have an issue. So you're constantly having that driving force of that moisture through if the slab's on grade. But once you have it elevated, you're really kind of forced with whether or not it's just the moisture in the concrete itself, or if you just have an issue like a broken pipe or something that's going on that's forcing water to go through. And one thing I just wanted to mention too is, you know, when we say our products are 100% RH, is because obviously they can take that amount of moisture. But, you know, some people understand that by saying, okay, so there could be literally like flooding water coming out of the concrete, and then you can put your moisture barrier on top of that, and that's going to stop it. No, I mean, obviously if you physically see water on the ground, that's definitely a situation that has to be looked at, and the moisture barrier is not going to help you there if there's standing water literally being forced through that slab. So.
The amounts of water that come in through a slab on grade, to build a little bit on what Elvis was saying, can be great. And the other part of it, and constant and continuous. It doesn't matter how long the slab's been in place. If you've got water in the ground and your vapor barrier has been compromised, it can be a forever situation. And the owner will probably tell you, hey, our basement is always wet. You're not going to get our second floor is always wet, for the most part, unless there are leaks, right? But the basement or the ground floor can have a situation of constant wetness. And again, being that I'm on the sales side of things, I think of things commercially. You now have a solution that not only gives them a great flooring installation, but is actually making their living space more pleasant and healthier to be in.
Okay, one question here. Will a handheld grinder be enough to prepare the slab?
So it all depends on the size of the slab. You can put different tooling even on a handheld grinder. And if you're doing 200 square feet and you don't mind being on your hands and knees, you can get the proper surface prep. On the other hand, if you're doing thousands of square feet and it's a commercial installation, or it's an installation where that concrete has been burnished and finished to a point that it's very dense, using just a handheld grinder can be a frustrating experience. Anything can be done. You can put enough pressure on a handheld grinder with the right tooling, with the right abrasives on the bottom of that grinder to get through almost any type of concrete. The question is, do you want to do 3,000 square feet of that? And I think part of the implications of the question too are, well, what do we do if we don't have expensive, large grinding equipment? There are substrate preparation contractors that you can subcontract, and I believe the cost for getting a CSP3 will probably range anywhere from $1 to $1.50, maybe $2 if it's a very difficult area per square foot. So if it's a small job that's difficult to get equipment into, it'll probably be north of $1.50 to subcontract that. If on the other hand you're dealing with a large wide open space, you may be able to find a demolition or prep contractor that can do it for around $1. By the way, these are very, very rough numbers that will change depending on where you are in the country. Is the labor union or non-union, and so forth. So forgive me if I told you a number, but in your neck of the woods may be completely different than what I just mentioned.
Yeah, no, I mean, to Joe's point, it's going to vary a lot. And again, it's really based on your situation as well. The pictures that we were showing, there was some serious cleaning going on because there was some serious contamination. I mean, literally you had adhesive that had re-liquefied, and again, it was sticky, it was all over the place, and you just had to get a clean slab. So if you're coming to a concrete slab that's fresh and new, okay, and again, you're not going to probably need that much of that much of prep. So it really varies on the situation. Every situation is different, and that's what makes this a very interesting segment to kind of talk about. There's just so many variables that come into play.
Okay, well, that is about all the time we have for questions today. Feel free to reach out to Joe and Elvis if you have additional questions. And if we did not get to your question that was submitted, the team will definitely follow up with you. To learn more about the products that were featured today, visit LATICRETE.com. This presentation will be made available on NWFA.org. Thanks again to LATICRETE for joining us on Hardwood Floors Magazine's Product Theater Thursday, and thank you for attending. Have a good afternoon.
Thank you.
Thank you for having us. This was a pleasure. Thank you so much.
Have a great day.
Bye-bye.